Good. So, since most of these questions were done in class in front of everyone, I will not go through all the explanations. But I'm still making this video because I still want you to see how to lay out your working. Right? So, number one says, when two freight cars of different mass collide and couple, what will be the resultant velocity? Alright, good. So we have two freight cars here. For every single conservation of momentum question, you always use this formula. Alright. So we have the first freight car, the second freight car. This crashes into that one. And what you say? Initial. Oh, please. For initial velocity, always use u. mu1 plus mu2 is equal to mv1 plus mv2. Well, m1, m2, whatever, but initial is always u, final always v. Alright, so the system before, the total momentum was m1 plus u1, m1 times u1, 10 tons times 4 meters per second, which is the initial velocity, plus 0, because it's 30 tons at 0 meters per second, which is equal to v multiplied by m1 plus m2. And I showed you why this was the case, because if v1 and v2 is the same value, you don't have to call it v1 and v2, let's call it v. So you have m1v plus m2v, which is the same as m1 plus m2v. And you have simple calculation, which will give you that. Alright. Next question. A 2 kg blob of putty moving at 4 meters per second slams into a 6 kg block of putty at rest. What is the speed of the two stuck together blobs immediately after colliding? Well, sorry. That is this question here. And that is the working. Very similar to what we did before. The football player, perfectly elastic collision. I had said that was a mistake because I didn't see the energies work out. But if in class I gave elastic, in a test I just say elastic collision, then you work it this exact way. If I do see elastic collision, that's exactly what you do. For when one object slams into the other, let me see. You still say total momentum before collision equals to total momentum after collision. Before the collision, what you do is say m1 times u1, whatever the value is, put it here, plus m2 times u2. u2 would be 0 since the second object would not be moving. It's equal to, when you come here, you would put 0 for v1 because v1 would not be moving after collision, and you put whatever is the value for v2 that was stated in the question, and you work it out, right? So this right here is not valid. I did explain how to do it in class. Alright, so next question. Alright, assuming that this is a perfectly inelastic collision, calculate the velocity after the collision in the example below. Now this example is with the grandmother and the child and the small boy. You see the working here. I'm not gonna explain this again because this is identical to what was done before. Let's look at the working. Notice how units are cancelled out. 4 meters per second. I'm gonna let that leave it as that. Alright. Question 5 is the same thing. That is the working of question 5. Before collision is equal to after collision. Just notice how you should lay out your question and answer it. Right. Question 6. It's the same thing. Good. Question 7. Alright, question 7 says, at 100 kV car is rolling down the street at 2.5 meters per second. How fast would a 500 kg car have to go in order to collide, to bring the system to rest after it collides? Alright, so that's the working there. Before we have our known velocity here, and after we have the known masses with the known velocity 0. The system must stop moving, and we see upon our calculations it produces -1 meters per second, which is correct because that's the speed that the car should be going to the left or up the street, if you want to say that. Alright, number 8. Was similar. A railroad car slammed into another railroad car. One was not moving. They combined, they moved together. That's it. Alright, number 9. 2 blocks were moving in opposite directions. Good. Now this question was answered correctly also. 2 blocks moving in opposite directions. Remember we said a velocity is a vector. So if they give you the being a vector, it will swing negative or positive, depends on the direction. We see the convention is up is positive, down is negative, right is positive, and left is negative. So in the diagram for number 9, we had a 2 kg block going left initially. So for total moments, total momentum before collision, this should be U1 is equal to -1 meter per second, because that block is going left. And when you see how to do the working, and this answer is 2 meters per second velocity. Right. Number 10. Alright. An explosion causes cars to move apart from each other. According to the diagram below, what is the speed of each of the cars as they move away from each other? So, well, that one would have been the same value regardless of position. It will be the same speed regardless of value, because total momentum before collision must equal to total momentum after collision. The total momentum before collision must equal to 0. So after collision must also be equal to 0. So whatever mass it is going to, whatever velocity, one will be going to the left and next one to the right, but it will always cancel each other to give 0. So assuming the masses are the same, whatever velocity the explosion would create, it might be 20 minus 20 equals 0, 40 minus 40 equals 0, basically infinite amount of solutions. So that's more of an explanation of that are working. Alright, number 11. 3,000 kg truck is moving right toward the speed of 5 km per hour and collides head on with a 100 kg car moving left forward at 10 km per hour. All these examples are so violent. The two vehicles stick together, wow, and move at the same velocity after the collision. Determine the post-collision speed of the car and the truck. Alright, this is all working there. The only thing what they should have been was negative 10 kilometers an hour. Because the car was moving to the left, this should be multiplied by negative 10 km per hour, and it will give you negative 1,000 km per hour. There's no way this plus could have just turned into a minus. So I'm assuming someone probably knows it should have been negative 10. Alright, so that gives you that. That's that. Alright, next. And number 12 is another perfectly elastic collision. So I'm just going to show you the working there. You can pause the video if you want and notice everything you have to notice. You see the negative velocity for left, right? Alright, but moving westward. You can say moving left also. Alright. Next, we have, it says calculate the velocity of the rifles recoil after firing. This question caused some confusion in class because the question did not give enough information as to say whether the bullet was in the gun before being shot, which I think is the only thing that makes sense, regardless of whoever on YouTube says. And besides, this video is also on YouTube now, so you can say YouTube says that the bullet is in the gun in the first scenario. Alright, anyway, in the test you will have a complete question with no ambiguity. Right, but we have a conservation of momentum here again, where total momentum before collision the total momentum, just the total initial momentum is equal to the total final momentum. In this case there is no collision. So this question assumes, yes, what I assumed, which is that the bullet was in the gun. So this was the mass of the gun and this is the mass of the bullet. So before collision, initially nothing is happening. So 4 kg going at 0 meters per second is equal to this should be negative. Oh, sorry, no, it's correct. 3.99 is a mass multiplied by the velocity. The velocity will come out to be a negative at the end. You don't have to put it as negative. Even though you know the gun will be going in that direction, you don't put it as negative because the reason why, because the value of the V, because it is going in that direction, will turn out to be negative. like how it happened, like how it did there. Right? The value of the V turns out to be negative. But if you have to put in V instead, don't put negative V. Because when the value of the V turns out to be negative, if you do have a negative V, you have a negative of a negative, which will make the actual V positive when the V is supposed to be negative. So just put 3.99V and it will turn out to be a negative number. Once everything is correct. Right? However, like this, if you have to put in the value of the V, and V2, we put in the value of the V, then you put a negative. Good. Oh, 1 second. Alright, next question. What is the velocity of the 8? What is the velocity of the 8 ball after the elastic collision below? Alright, so this is number 14. Here we have the 8 ball being 2.5 kg. Alright. So, oh, sorry, this was a mistake. This question is not correct. Elastic collision, this was for totally inelastic collision. For the elastic collision, what you do, alright, I'll answer that question in the other video.